Okay, so we're going to look at the absolute max and the absolute min. So those are the very highest y values and the very lowest y values. So if I was to look at this looks like the absolute lowest y value. So I'm just going to call it -7, and that looks like a -3. So an absolute minimum would occur at f of -3, which is -7. So -7 is truly the minimum. All right, so what about the maximum? The very, very highest, that would be this point, right? So if I call this 5 and call this 8, so the absolute max occurs at f of 5, which is 8. So that's the highest y value. All right, so the local extrema, this maximum has got to be where there's a peak. There's a value, there's y values around, or x values around that y value, that's the largest, and the minimum is where there's going to be a valley. Cannot be an endpoint. Okay, so let's look for local max first. So local max is coming down, going up. Okay, I see a region around this x value, so let me call it -2, and I'm going to call it 4. So there's a local max at f of -2 equal 4. So that's the highest y value in that region. All right. So this is not a max. This is not a max because it's not a filled-in endpoint. How about this? So that was our absolute max, but that is also our local max. So a local max of f of 5 equal 8 is true. All right, so that's all the maximums. So let's look for the minimums where there's got to be a valley. So right here I see a valley around this point. So local minimum would be f of -3 is -7. So that's the same thing as the absolute minimum. And then let's look at this point right here. There's a valley around this. So let me call that x equal 1. And let me call that -4. So a local minimum at f of 1 equal -4. This is not a local minimum because there's not a valley around it, but this is right here, right? Because I've got a valley around it. So that let's call that x equals 6 and y equal -1. So local minimum at f of 6 equals -1. All right. So let's continue on with these pictures. So if I was to graph this, it looks like this. So I want the absolute max, the absolute min, the local max, and the local min. Okay, absolute max, there's none. I can't find an absolute max because there's an open circle at the end, right? There's nothing to get to. Absolute min, right there. So you always want to say f of 1 equals 0. So 0 is the minimum, but you want to say where the x value is. Local max, there's none because there's no peak, right? Can't use an endpoint. And same for this one. There's none because there's no valley. All right, let's look for this one. Absolute max, absolute min, local max, and local min. Absolute max looks like right here. And because you know the graph of sine, you know that's f of pi over 2 equal 1. How about absolute minimum? Well, it's going to be those 2 points, right? F of 0, which is the same as f of pi, which is the y value of 0. That's the absolute min. Local max, that's the same as the absolute max because there is a region around where that's the highest y value. Local minimum, none, because there's no region around either of these endpoints. All right, let's go to this one. Absolute max, absolute min, local max, and local min. All right, absolute max. It does go to that point, so f of 2 equal, I'm just going to put 2 into the function, 2 to the 2/3. Is there an absolute minimum? Right there, f of 0 equals 0. Okay, is there a local maximum, a place where there's a region around where it's the highest? Nope, because this is an endpoint. You can't have a local maximum at an endpoint. And local minimum, where there's a region around, right there. So f of 0 is 0. That is a local minimum.